So I've got the QR code, and I understand that most of you are probably on your computer. So I'm going to drop the same link to this form in the chat. And if we can take about 5 or 6 minutes to fill it out, I'd love to just quickly see what role you are in your district, what specifically about this session was interesting to you, and that way I can kind of guide the discussion to flow a little bit more along those paths. I noticed a couple people just joined, so I'm assuming they don't see the old chat. I'll post it in again. So yeah, if we can take about 5 minutes to either scan the QR code and fill out the form, or just fill out the form that I posted here, so that way I understand your role and your interests a little bit better. Oh, one more person. Okay. Ah. Okay, we've got, let's see, 13, 14. So common themes, by the way, so far. Basically, almost everybody has said they're interested in more hands-on PBLs, project-based learnings. Basically, everybody, except for 2 people, I think, have said they want a way to embed STEM and computer science into the core curriculum. So you're in the right place. And a couple people have talked about maker spaces or innovation centers, and a couple people on AI. I think we're still waiting for, so I have 14 people filled out so far. Are we waiting for 5 more? I'll give it 1 more minute. And in case you weren't here when I sent this form link, it's in the chat. Also, same thing as the QR code. All right, I'll give it 1 more minute. Currently have 16. So there, let's see.
Hi, I'm a little confused. Am I supposed to be filling out a form?
Yeah, do you see the form that I posted in the chat?
Yeah, but it's a post link. Well,
it's a what link? No. The form that I posted is a form that I made. This is different from the survey.
Okay, I'll try again.
Yeah. And worst case, you can try scanning the QR code with your phone and do it on your phone. Yeah, same link.
Yeah, it says follow up. Is that what it's supposed to say?
Oh, well, okay. Yeah, it's a form that I usually use after,
Okay.
but in this case, it made sense to do it at the beginning. Sorry about that. Yeah. That's a good point. Okay, got 1 more. Okay, anybody else have any issue with the form? All right, it is 32. I will go ahead and start now. So fundamentally, we're seeing that every single job is totally changing, right? Like innovation is everywhere around us. But I want to start before all of that with who the heck I am and like why I'm doing what I'm doing. So back here, this is me in 7th grade. I was a percussion, or actually 8th grade. I was a percussionist. And I was like very into like making inventions, but that like kickstarted a thing that quickly morphed into interest in computer science as well. So one of the first ever projects I did, or at least attempted to do at the end of 8th grade, like in the summer before 9th grade, was I am a big fan of Android. So there was one feature that iPhones had, which was basically you could press and hold a word and then click the define button and it would just like pop up a little card with the definition. And for some reason, Android has just like never had this feature prior to like 2 years ago. So I was like, my mom's a software engineer. She should be able to mentor me and help me make this app. I'm going to make it for Android. Turned out I had no idea what the hell I was doing. So it was very confusing and I kind of gave up. But then I tried again after I took AP Computer Science A in 10th grade. And my AP Computer Science A teacher was fabulous. She told us, all the basics about objects and how they're stored in memory. And she explained how everything worked. And I was like, man, I really get this. I'm going to try again in 11th grade. And then I realized what we learned was kind of useless, or at least it wasn't the right stuff. There was a slight misalignment between what we learned in the computer science class and what we needed to make a functional product, right? I still didn't know how do I fetch data from somebody else's servers? Like if I wanted to get the definitions from Merriam-Webster, they're sending me this like JSON thing. Like, what is that? What happens if I don't use all the data? Like, will my app crash? Actually, the answer is no, but I didn't know. I was just scared. I just had no idea. And that kind of persists, right? Even throughout computer science curriculum to date. And then the other thing I used to do in college was I used to run these inventathons back in Houston, where basically our largest one had 204 kids from 19 schools across Houston. And we had it at an innovation lab center in Houston, where we would bring in a bunch of mentors across different disciplines, and students would have access to 3D printers, laser cutters, electronics tools, etc. And they got to make an invention in 2 days to a particular theme. So these students right here were from kind of an underserved part of Houston, but they had an awesome idea. So they, instead of brushing your teeth for 3 minutes, made a mouthpiece with bristles all the way across. So you pop it in 3 seconds, all your teeth are done. So awesome idea. But they had never done electronics or coding before, right? They never had exposure to that. So they were able to make a looks-like prototype in that 2 days, but not a functional one. Fast forward about a year later, and somebody else put a really similar idea with a functional prototype on Kickstarter and raised $8 million. So it could have been those kids. It could have been a life-changing experience for those kids. And that's really why I'm here. I want to make sure that, as we see literally every single aspect of life, from sports to film production, to agriculture, to things that we use on a daily basis, are being totally revolutionized by STEM, computer science, and AI, right? So how do we prepare students for that world, regardless of what topic they're interested in? How do we make sure that they're productive citizens? And also, if you haven't heard of this virtual film production thing, holy crap, it's awesome. So basically what happens is, instead of actors acting in a green screen where you kind of can't see anything, the new technique is they're using a video game engine to project the graphics in real time. And then the director can say, hey, I don't like the sun. Can we move it over to the other side? So the actors can see what's going on. The lighting is all real. And then there's not as much editing later because it's all captured in the camera. And then the sports motion capture, if you watch like the NFL, like the Buffalo Bills quarterback, Josh Allen, went from the least accurate quarterback in the league to the third most accurate in 1 year, because he went to this facility where they used a bunch of cameras in an AI model to analyze his sports form as he was throwing. And then they realized that he was throwing before his hips had fully turned. So he was not getting the full power and torque from his hips. So, and plus he would sail wide. So they fixed that. And now not only can he throw even farther, he's like laser accurate. So I did an analysis of a lot of the new jobs across industries. So both looking at the Bureau of Labor Statistics data, as well as interviewing leaders across a bunch of these fields. And it turned out that constantly we'd keep seeing that these core technology skills were popping up over and over, that AI was being used, like I said, in sports, or web development is being used in agriculture, or same thing with internet connected electronic sensors and physical products, as well as AR and VR. So right now, right, computer science is often a separate course. There are some logistics issues with that, right? Because a lot of you are teachers, but I remember some of you in like one of the other sessions mentioned, you were like a math teacher before and you're converting over, but how can we make this more sustainable, right? That every single student gets these skills and it's not just a one-time thing, but it's something that's part of students' identity. It's part of who they are, how they approach the world, and make sure that we set them up to success in core course standards, computer science standards and skills, as well as for cutting edge industry applications that could eventually earn them a job that pays, like potentially 70K straight out of high school, all the way up to 150 to 220K after they graduate from college. So the other piece is also like the identity piece, right? How do you make sure that every single student feels represented? And you'll see from a second that like our team is actually super diverse as well as the sort of guest lecturers that we bring in. So I want to show you what some of our projects look like. We have projects
is to like, hey, who's the top
that integrate into the core
influencer?
content.
Things that they're actually interested in, to be able to use a
From
professional
English,
program
where
Tableau
students recreate,
and use videos taught by a former Google AI engineer in order to create a really awesome project.
So we have students create a wildfire spread simulator. We have them in English analyze stuff with Tableau,
and then they take
or
it
build
to
and code a Nintendo Switch.
Fusion to do the actual assembly, like say the
Or
background
in world history, we create a historical empire as a video game,
and they're
using the
researching
same tool that
social
Fortnite is
studies
built
topics and learning really. Also taught by the CEO of a real video game studio company.
So that's kind of what our projects look like. What we're basically trying to do is integrate STEM and computer science and AI skills throughout the core curriculum that every kid has to take, right? Because if you think about it, like if I have to recruit kids to take this one computer science course, like, I mean, even the Skillstruck guys were talking about this earlier, there's sort of like an identity thing, like maybe the class doesn't seem cool. But if we put it where kids already are, then suddenly that's not a problem anymore, right? We don't have to recruit kids to take a computer science class. They just automatically get it in the same way kids automatically get math and English and social studies. And the other benefit is by embedding a hands-on project using these cutting-edge skills in the core courses, students get multiple repeated exposures, which is one of the most important things to retaining learning long-term, right? Is you get repeated exposures, see the same thing, and see how what you're learning connects to things you already know. So what some of these projects look like, I mean, you saw a little bit in that video, is things like in world history class, recreate an empire as a video game using the same tool that Fortnite is built in. Or in English, use Tableau to publish a blog with interactive data visualizations where students get choice on what topics they're actually visualizing. So it's not necessarily that everybody has to, read Crime and Punishment and write an essay about that. Something that makes students have a little bit higher buy-in. Or especially in the West Coast, right? Or like that area of the US, wildfires might hit close to home, quite literally, I guess. So we've been creating a simulation where students get to see how computer science actually affects all aspects of life, even agriculture and natural wildlife, right? So every time we design a project, we try to do it in a way by interviewing students and asking, what topics they're interested in. Like this music synthesizer came from students saying, oh, we love making beats. And we also look to what are the cutting edge areas in the industry that we can pull from and kind of bring in. So I want to show you what one of our projects looks like. This one specifically, recreate an empire in Unreal Engine. So what we give students is basically the 3 weeks worth of lesson plans that they walk through, right? It's the actual instructions for the course. And so the way we design our projects is every unit basically integrates the core content standards for that 3 week, like 1 unit of time. So that way, instead of like a traditional worksheet or something, students can do a technology integrated project where they're building or coding or designing something and cover the same core standards at the same time, as well as those computer science standards and industry applications. So for this Unreal Engine project that you'll see in a second, we gave our students a suite of what we call TikTok length, but masterclass quality tutorial videos led by the head of a video game studio, who was sort of our guest lecturer. And we have instructions where students actually walk through how to recreate a historical empire. They get to choose one of the empires from a list. So there's an aspect of student choice. And then we give them a library of assets, or basically parts. So they get like windows and doors and roof pieces, but they have to analyze which pieces are historically accurate for the civilization that they chose. And then from there, they use the tutorials to piece it together, write an actual blog article kind of describing their choices and the research that they had to go through and which primary sources inspired their design choices.
My name is Kai McNeil. I'm 15 years old, and this school year I'll be a junior at Kaufman. So during the summer, I've been a teaching assistant at Operation Breakthrough Ignition Lab, and one of the projects that I picked up was recreating an empire in Unreal Engine. So this is my recreation of Tokugawa / Edo era Japan. I wanted to keep the landmarks, I wanted to make sure that it looked really cool, but it was also realistic. So the houses that you see are all realistic to the time period. So I have the marketplace here. This shrine is, I thought it looked really cool, and it was in a drawing of another that a Japanese artist did at the time. Here we have a temple complex. Wanted to make sure that I put a temple in because it is a Japanese city. A lot of them have multiple temples. So yeah. So what I wanted to make sure that that my city looked like was I wanted to make sure it looked good at night. So I know that it looks good in the day, but I didn't want it to be nighttime and then you can't see anything. So I'll go ahead and turn nighttime on so that you guys can see what it looks like. So as you can see with the temple, regardless of the time of day, you can see pretty much everything really clearly. And the same is true for the marketplace. So the marketplace is a really fun place to walk through at night, just because everything is so bright and it looks more lively than it does in the day, just due to the fact that the surroundings are dark, but you can still find your way through each of the paths. All right. So now I'll talk about the research that I had to do to get to this point. So I knew very little about this era in Japan. In history class, we started at the era after this. So, this is kind of unknown territory for me. So, um, the most reliable resource that I found was a book about Japan that was actually written by a Dutch person. So, this was a a book that was written in a completely different language that I had to translate. Um, thank God Google Translate exists, because that would have been a lot more difficult if it didn't. But yeah, so this was the main inspiration for my temple. As you can see, it's another Buddha temple. This one was located in Nagasaki, but a lot of them, there's a lot in Tokyo that I drew inspiration from. And yeah. So I also looked at a map from the time period, which was pretty rare because maps of Japan before the Westerners came were few and far between. Um, and yeah, so I'll go back to this, and yeah, so as you can see with the temple over here, this is kind of a mix between Sensoji Temple in Tokyo and the temple in Nagasaki that I saw in the Dutch book. So some of the technical things about this town are I combined a lot of different assets for this. So think, like, for example, this house. Think one house has maybe, think the fewest is 45, the highest is a little bit over 100. The temple definitely had a lot more assets, but the cool thing is once you get all the assets together, you can group them and mass produce them. That's why instead of taking me months, the marketplace took me closer to a week. So yeah.
Okay. So I have a couple of questions for you all based on what you've seen so far. And so this part is definitely going to be more interactive, right? Because I want to hear feedback from what you guys are seeing and hearing so far. So in that video that you just saw of the student who recreated 1800s Japan, how do you feel like the depth of analysis was for the social studies piece? And then secondly, what computer science concepts did you see, I mean, again, briefly, in that project? So I'll give you guys a minute or so, but like, I mean, if you have, your thoughts immediately, then feel free to chime in right now.
I'll say something to get us started. I think it spoke to the strength of something that's a passion project. That student was very clearly interested in learning the content that he was researching.
Yeah, absolutely. And like, I mean, in the description, right, I wrote, too often we teach computer science as, here's a little bug, move it up a couple steps, or here's some random numbers, let's go sort them with a for loop. And if you think about it, like, how does that relate to what we actually use on a daily basis? How does that get me excited? I mean, unless I already care about computer science as a concept, unless I have a mentor in my life who does that, like my mom, right? How the heck am I supposed to get excited about that versus exactly what Heather was saying? Like, let's ignite kids through a certain passion.
I think it gives students a direction, where so many, I mean, in the area where I teach, so many come just to, oh yeah, we get the computers, we get to work on the computers, or whatever. And I think this just gives them direction and it would keep them more focused and more engaged in the lesson itself. If, like she said, with the passion project, I think that's priceless, to give them a direction, because so many of them think they know the direction they're going to go, but by
Right.
giving them something like this, I think it helps them to find a true direction, instead of just messing around, goofing off or on the
Right.
computers.
Right. So yeah, I'm seeing passion project, game design, animation, using the actual structures, providing the history connections, make students actually want to learn more about the history. Yeah, absolutely. Breeds discovery. Yeah. Those are all, I mean, hey, we've tried making a ton of tutorials and projects, and it took us a while to kind of get that formula where it really allows students to have that sense of discovery while still having enough rails and enough supports with the scaffolding so that students don't feel totally lost. And so Josiah, is that how you say your name?
Josiah, yeah.
Josiah, okay. So great question. All of our projects, except for the ones at the last level, pretty much, are designed for students, assuming that they know absolutely nothing about the topic. So this kid had, the student had once toyed around in Unity for a day, and really didn't know what he was doing. Right. I mean, that's the kind of experience that I would have done in middle school or high school as well. But basically, and I can show you an example in a second. We have a collection of 80 tutorials, I think, for this project that are all bite-sized. Most of them are 2 minutes or shorter. So you don't have to wade through kind of a half an hour lecture or something trying to figure out what the heck is actually relevant to what you're doing. It's really easy for students to pick and choose the piece that they need to solve the current problem. And so we found that this structure makes it a lot more accessible for novices as well as experts, right? Fascinated architecture details. Yeah. So someone a little earlier said something about student directed and how comfortable the school might be with that, especially with the standards. So the really tight needle that we've been trying to thread with all of our projects is tying every single one of our projects to at least 1 unit's worth of core content standards. And some of our projects actually hit more than that, and it's kind of fun. So we generally want to make lives of teachers as easy as possible, right? Oh, 1 second. I want to try something slightly different because I don't have a video to share yet. Okay, so that way I can still see your faces. So for example, every one of our projects pretty much also has a pre-test and post-test in the core content area. So this project for Algebra 1, or if you do an integrated math, generally it covers slope of a line, system of equations, angles, and how that relates to slope, as well as inequalities. So basically, it's the Pong game, right? Paddles move up and down, the ball bounces, and eventually you score and stuff. So that one project, between the pre-test to post-test, when we had students do this project, students' scores in that unit of algebra improved 18%. And we had we had students in the alternative school as well as the regular high school do this project. And one of the students in the alternative school, apparently, we did this in project in March at that school, apparently had never talked in the entire class up until March. And then by the time this project rolled around and he got into it, he actually came up with a more efficient algorithm to detect when the ball is bouncing and then flip its angle than what I had in my answer key source code. And so this was really fun to see where, all of the students were problem solving together, and they had a whiteboard wall on the back wall. So the entire wall was a whiteboard, and the entire wall was filled with, it started at pseudocode of okay, here's what this map looks like. Here are what the locations are. What does it mean when the ball is bouncing? That means it's hit something. Okay, so we need to have a function that detects whether a ball hit a paddle. Okay, what does that function need? And so there's a way that we like to start sort of top down, describe things in plain English, and then we keep adding detail to each of those steps until you approach a mathematical equation, or you approach like some other library of code that somebody else has already written. For example, a way to interact with like the button, or a way to start the buzzer. So that way, I find that doing that often is a lot easier for students to grasp, and it makes that transition from like elementary, where maybe they've done a little bit of Scratch, but not really seeing how real products come together, a lot easier as well. And then this project for students to publish a blog article using data visualizations with the Tableau software. Our guest lecturer for this project, which you probably briefly saw in the original video, is Justin here. And he is a former AI engineer and technical program manager from Google, and is currently getting his MBA. So we really want to put student or like people on screen that at least have one option for every student that they can say, oh, I want to be like that person. That person is like me. I get it. And so in this project, they use Tableau, which is a tool that could get them a job that pays 100K. And even in our instructions, we talk about what additional skills they can kind of stack on it. For example, getting more familiar with Python and some of its data science libraries, or using SQL to directly talk to a database, which could even bump that salary higher. And we also talk about, hey, like sports teams use this, schools districts use this to analyze student performance. Shipping companies use this. And you can also use this to analyze video game sales, or sneaker sales, or your favorite TikTok influencers, or cars, or housing prices, right? And so we really allow students to choose a subject area that's interesting to them. And then we use that little bit of student choice and agency to have a sort of standardized practice and standardized process, which makes it easier for a teacher to facilitate. But then also makes it easier for students to get involved in the ELA, right? Because maybe as a student who doesn't care about ELA yet, I don't care about Crime and Punishment, or I don't care about To Kill a Mockingbird. But then I do a project where I get to learn a lot of the same technical writing and reading skills. And I realize, wait a second, I actually enjoy this. Then, once that buy-in, once that story and that why school matters has been created, now students can actually buy in and go one step further with the ELA and so on. And then I want to show you a couple of quick quotes from students and teachers as well. So we had a project for students to design their own circuit board. We're testing that one right now. And the thing that I always like to emphasize is these topics are all connected, right? It's a network of ideas that build on each other. So Nairi was really into graphic design, and she had made like her own logo and all that stuff. So we had her do this circuit board project where she had to lay out the components to make sort of like an LED sign version of her name. And in that process, she realized, wait a second, laying out the traces of copper that connect one component to another is a lot like graphic design. And there are rules in terms of like, we need to have a certain amount of spacing between a component and that strip of copper so that there's no interference. And we have to have constraints such that the trace of copper is wide enough to carry the current. And a lot of that also feeds into web design, where you're using like CSS or HTML, right, to design a website, but it has similar kinds of constraints of like how the components fit together. So we really like to emphasize those cross connections as well.
Excuse me, I hate to interrupt, but we're seeing a spreadsheet on our screen. Are we supposed to be seeing that or something else?
No, you're not supposed to be seeing the spreadsheet. Thank you for telling me.
Yeah, okay.
I thought I did desktop too. Okay, there we go. Sorry. Okay, well, let me just quickly show you the thing that I said like over the last 5 minutes. That's Justin right there at the end. Tableau, the process standardized, but kids get unique inputs, so they get buy-in. All the different data sources. This is Nairi. Okay, sorry about that. Thanks for telling me. And another one of our students, Jacqueline or Jackie, she was one of the first students to do our project where they got to code a COVID spread simulator in statistics class. And we were like designing this virus simulator project before there was a virus. And so we just kind of got lucky, but none of these students had ever coded before. And not only were they coding, but by the end of it, they were using a lot of the data science and AI tools in Python to actually build the simulator. And so with this project, 87% of the students wanted to see a project like this in all of their other classes. And basically every time we have a project, we have the students do a presentation at the end where they're actually the teachers. So we break up the project into like 5 to 10 steps. The students team up and they're actually teaching what they did in that step of the project and showing their results. So that way it's sort of like the Richard Feynman technique of learning, where if you can explain something clearly to a novice, that shows you've actually understood it. And sometimes it takes that explaining process to really understand it. And so we brought in the vice president of the University of Pennsylvania to see their presentations, all of the parents. So these types of projects give you a really powerful opportunity to make learning visible and to engage the community as well. So I'll pause there again. Do you guys do any sort of community engagement with parents? And relatedly, how do your parents and communities even feel or think about computer science? Like, is that something that people see as a priority, or is it sort of, I'll just stop there. Yeah.
Hi, Nico. Hello, can you hear me?
Yeah, yeah,
Yeah, my name is Keon Pierre from Woolley Elementary School. What I would say is that I'm also a robotics coach, and I also do for the summer school the robotics and computer science for all the grades from K through 5 during that period of time. But what I would like to say is that last year we had our fall festival, and in that festival we had different booths and stuff and games and stuff, so it would get the community involved. And one of my booth was a robotics booth, so I set up a game with robotics, and the feedback from parents and kids was tremendous. So in that sense, I know that they gravitated a lot. And this is a Title I school. This is in an area where the economic situation isn't all that good, but the turnout for this was tremendous. I would say, and even parents were involved in playing and participating in it too. So for my area, for my school, with the parents that I have and with the students, they are highly geared to do computer science and to learn from it. The last time I did a seminar like this, there was another personnel who was giving or sharing information on, like, I think it's an hour of code or something like that, that you can get the parents involved in that, after school stuff. Yeah, but I hadn't have the time to get that on track yet, but I'm looking forward to do something like that come next term.
Yeah, for sure. And also, like, one piece that I like to think about is a lot of districts do that kind of fall STEM night, or like they'll do a STEM
Yeah.
night. Like, you know, usually for some reason I see it like in somewhere between October to December.
Yeah.
Imagine if you could have not just one of those sessions for a couple of hours, but, you know, kids are doing projects in our sort of system that we're talking about, right? Is they're doing a project in each of their core courses every year, which
Mhm.
means parents get to see approximately quarterly, right, what progress their students are making and what new application for computer science and STEM that they're seeing. So it's not just sort of one touch point, but you see it over and over. And you know, there's no extra organizing, right? Like you just send out one email, here's the Zoom link, and the family kind of hops on as they need. Also, where exactly are you, Ken?
I'm in Las Vegas. Yeah.
Cool. It's interesting because your shutters look exactly like mine.
Oh, okay.
Okay, I see Ray wrote something. They know it's important. Ray, where are you in the state? Okay, you're also in Vegas. I guess I should look at the spreadsheet. So for those of you who are maybe not necessarily in a central, like a city center, or have students in general maybe interested in agriculture and agricultural technology, I'll give you two examples of what projects that I've done personally or seen personally, and then what we're looking to incorporate into our sequence of projects as well. Is so one of my really close friends from college came from a rural-ish part of Ontario. So his parents had a 400-acre farm. And one of the things that he told me, and I was just like mind blown that like people were okay with this process, is apparently they have these sticky pieces of tape that they plaster every couple of acres. So somebody manually walks the farm every couple days, and they analyze this piece of tape to see what bugs have stuck on it. And then once they know that information, they can, you know, write it down on their little notebook and come back and see, oh, where do we need to spray pesticide? Or where do we need to put some other crops around to, you know, prevent the pests that are coming in? And, you know, it's Ontario, right? It gets cold. I mean, just like where it gets for you guys, blizzard out the window, right? So he and I created this. I mean, honestly, it was pretty basic. Like we didn't do anything all that sophisticated, but we got a Raspberry Pi, stuck a camera on it, and then used some really basic computer vision to count the number of blobs on the picture. So we just stuck a camera in front of these sticky tapes and just counted the blobs. And so we saved people from walking around the farm, because this camera can now send the number of blobs up to the internet with the picture, so that somebody at home on their phone can analyze, oh, I'm seeing a certain type of bug in this region of the farm. Okay, we should spray pesticide there. And you know, that type of project we're looking at with our internet connected electronics projects, to have students actually go out sort of into the community, probably in an ELA course or a bio or chemistry course, to see how some of those things can be applied to problems that they already see. And then give students that sense of agency within constraints on actually solving that problem. So we're trying to make it as easy as possible for teachers to facilitate with really strong, clear instructions, but give students that little piece of voice that allows them to really, you know, make it their own and understand how to solve problems that are meaningful to the community. Yeah. Tiffany, are you trying to say something? Because you're muted.
Sorry, I was just commenting. That just sounds very, very cool. I think that the kids would really enjoy something like that.
Yeah.
My only problem or issue is, what do you do when kids are not engaged and don't want to do those community projects, or what I'm encountering is when they want to misuse their computer and they want to go into other areas. I'm finding that I have most of my kids that are very engaged in projects and they love doing it. They love learning, but then I've got that segment of students that don't want to. So do you give them like maybe another project for those students that don't want to do that particular project? And then what do you do for kids that kind of deviate from the plan?
Sure. Yeah, so those are great questions. And then I do want to use a lot of this rest of the time to get feedback and find those weird edge cases from all of you all. So I expect most of you to talk at some point in the next 15 or 10 minutes, whatever the number is. So for that, I've actually experienced where in one of the schools we worked with in Kansas City, students were watching full-on Netflix movies on their phones. And they would never raise their hand. So you wouldn't know if they were stuck as a teacher, right, or as a facilitator. So one of the things that we're developing right now, and I can quickly share a mock-up of it and love to get your feedback on that, is the following. Basically a phone view for teachers where they get to see all the students in their class. But what it does is automatically it brings up the students who haven't done anything for the past couple of minutes and tells you what section they're on. So you know that they're probably stuck. And also if there's someone who's waiting for feedback, it brings that up as well. So that way you can go and directly talk to those students. And then sort of the next page that you would also see is some common places for students might get stuck or might get disengaged, and some tutorial suggestions. Because I found like with one of the students is it's not that they didn't want to do the project, but they thought it was some parts of it were, you know, beyond what they were capable of, which was not true. And all they really needed was somebody to sit next to them for like 20 minutes. And so one of the other features that we're doing in most of the projects is making them like a pair project. And then one of the pieces from learning science research that I found is, you know, a lot of times in pair projects, it's very easy for somebody to just go along and not kind of do anything. So if you see that kind of behavior, or you know one student is weaker or otherwise, right? You actually have them flip who is typing every couple class periods. So that way both people have to type and both people have to think. And so I think there were a couple of studies, I think one out of Northwestern, that talked about this and showed like remarkable improvement, right? So that's one of the practices we're kind of including in our teacher guides as well. What other questions or general comments do you guys have?
I think it's great. I'm excited to see this because I see us is getting younger and younger. Kids are getting introduced earlier and earlier, and this is exactly what they need. Has there already been communication with CCSD about, or with the different school districts in Nevada to bring this into the classrooms, or what? If we wanted to bring it in, what's the next step for us as teachers?
Yeah, I think the next step for you would be to email your computer science director. And in Clark County, at least, we've talked, and actually your computer science director offered to be a mentor as well. Yeah, I mean, the big question is who's interested, right? Like, so yes, I think the first step would be email your computer science director. And I can, since I have most of your emails now, I can send you sort of a template or some sample wording. That way it'll be, you know, you don't have to like sit for an hour and craft something. Yeah, so, and then also to the earlier question, this is initially started out as middle school and high school. But we've had a lot of requests recently for like lower grades. So we actually started developing a couple of elementary school projects. I don't want to do something that I think other people are doing reasonably well. So we started with some of these projects to teach in a different way. So for example, teaching computer science and design for like a web app or something, right? Through understanding and analyzing a student's favorite app and seeing how that actually works. And like, when does the server send data and receive data? What data is actually being stored about each user or each movie theater if your favorite app is a movie theater app, for example.
And I am going to say we are out of time, actually 2 minutes ago, which is a great indication of an excellent session. And I won't cut you off if anyone wants to continue and talk, and our presenter has time to. But I do just want to point out that I put the session evaluation link in the chat. So if you are tracking your attendance in order to get professional learning hours for this event, make sure you complete that session evaluation. And I do just want to extend our thanks for a really thought-provoking session.
Awesome. Thank you. What is the name? That's a good question. Let me see what I actually called this thing. Or actually, if someone has it, yeah, there you go. Integrating real world computer science and AI. Anyone have any AI related questions? Because I realized I didn't talk a whole lot about AI specific projects, but if that's something you want to ask while you're filling out the form, feel free.
How do the students, how do the students learn the AI on the, and how to teach as a teacher? I don't have much experience. I haven't had any experience with AI, but I want to bring it in.
For sure. Yeah. So, I mean, if you were to really teach how these things work, you technically need to teach linear algebra and you sort of half want to teach calculus, but actually you can sort of go the other way around. I think it's Tiffany came back in. But really what we like to do with basically everything, our view is let's teach top down, right? Like, let's start from plain English and then work with more detail, like peel the onion, right? Like ogre's gotta have layers kind of thing. So one way we start is with having students use like ChatGPT, for example. One of the projects we've been working on for elementary, like I was like at dinner with a random board member and he was telling me, oh yeah, my daughter loves books or like loves princesses and dragons. And I was like, oh, wait a second, let's use ChatGPT and work on a prompt such that it makes a story about princesses and dragons appropriate for a second grader that has a twist. And so have students get exposed to AI by actually using the tool. And then basically like a regional director in Pennsylvania suggested, can we add more to this prompt so that we get alliteration? And so what is that prompt engineering? Like, this is actually the term now. How does that process work? How do you get students to learn how to get the tool to actually deliver the output that you're expecting? And one of the things that we were, again, these are smaller activities. We're slowly integrating them into a bigger sort of middle school and high school area project is, like, think about like your Apple Watch, right? If you have an Apple Watch, how the heck does it go from this green light blinking randomly into suddenly knowing your blood sugar and blood pressure and blood oxygen level? Like, what the heck? How does that work? It's actually this process called signal processing. And technically, this process requires matrices. But basically, what's going on is you take a bunch of example data and then you correlate it with readings from an actual real-world machine. And so what this AI is actually doing is creating sort of a filter or a transfer function that converts readings from this one type into the outputs from this other type. And so we actually are working on a project for students to do that process.
Awesome.
So, yeah.
Thank you.